The last class we have started Mohr circle in a 2D plane and we have discussed the two cases. Today we shall continue this topic. In the last class what we have seen that Mohr circle is a graphical method for finding normal and tangential and resultant stress on an oblique plane, and it can be drawn for three cases. Out of those three cases, the two cases what we have discussed was like this. A body subjected to, the first case was a body subjected to two mutually perpendicular tensile stress of unequal intensity, means we have a body on which two tensile stresses of same nature, means both are tensile and of unequal intensity we are there, and we have drawn the Mohr circle to find out the normal, tangential and resultant stress. And in the second case, we have drawn the Mohr circle when a body was subjected to two mutually perpendicular stress of unlike nature, means one was tensile and one was compressive and of unequal intensity. In the third case that we have not completed in the last class was like this. Body subjected to two mutually perpendicular tensile stress with a simple shear stress. So in the third case, we are going to discuss when a body is subjected to tensile stresses as well as shear stress. So in order to move forward to the third case, first of all, we will revise or see the steps that were used to draw the Mohr circle for case 1 and case 2. So the steps were like this. So as you can see that the first case was like this, and I have also told right now. So in order to draw the Mohr circle, first of all we need to draw a horizontal line AB, and on this line AB we will represent sigma 1 and sigma 2, both the tensile stresses, after converting it on a suitable scale. So AC represents the sigma 2 and AB represents the sigma 1. So both of these two normal stresses are drawn on this line AB. So B and C are the extreme points of the circle it is considered. So BC is the diameter, and half of or the midpoint of this diameter would be the center of the Mohr circle. So considering O as a circle and OC or OB as a radius, we have drawn this Mohr circle. So once the Mohr circle has been drawn, now we need to locate the oblique plane that was at an angle of theta. But in Mohr circle, it can be located at the double the angle from the particular plane. So that's why we have drawn a line OE at an angle of 2 theta in order to represent the oblique plane. Whereas in real the plane was like this at an angle of theta. So CE is the real position of plane, whereas OE is the position of oblique plane in Mohr circle. So once the plane has been identified, a perpendicular from point E has been drawn, and this ED represents the shear stress, whereas this AD represents the normal stress, and resultant of this ED and AD is equal to AE. So this one is the resultant stress, and angle of the resultant stress with the horizontal is phi, that is called as obliquity. So in this way the first case was discussed. Whereas in second case, the body was subjected to two mutually perpendicular stress of unlike nature, means one is compressive stress and one is tensile stress. So tensile stress can be taken as positive, whereas compressive stress can be taken as negative. So here sigma 1 is the tensile stress, it is considered as positive, drawn on the right side of A, and sigma 2 being the negative or compressive stress is drawn on the left side of A. So BC are the two extremities of this line, and it can be considered as the diameter of the Mohr circle. That's why O being the midpoint is the center of Mohr circle. So with this O as a center and OB as a radius, a circle like this has been drawn. Then after we need to locate the oblique plane, again it has been located at an angle of 2 theta. So OE has been drawn. So this is the oblique plane But in actual, the oblique plane is at an angle of theta. So C is the real position of oblique plane, and in Mohr circle it has been shown by OE. Once point E has been located, a perpendicular from E has been drawn as ED that will represent the shear stress, and AD is a normal stress, and resultant of AD and ED is drawn or shown by AE. So this is our resultant stress. So we can draw the Mohr circle and find out our objective, that was to find out the normal stress, shear stress, and resultant stress. Now let's move forward for the third case. So third case is like that: a body is subjected to tensile stress with a simple shear stress. As you can see in this diagram, the face AB is subjected to a stress of sigma 2, the face BC is subjected to a stress of sigma 1, and it is accompanied by a shear stress of sigma on all the faces. So now let's see the steps how to draw the Mohr circle. So first of all, again we need to take a horizontal line through A, and on that horizontal line we will represent sigma 2. Sorry. So first of all, a horizontal line has been taken, and on this line we will represent sigma 1 and sigma 2 towards the right from A on a suitable scale. Towards right, why? Because the nature of the stresses are same. Both are of tensile nature. If one of these two stresses would be compressive stress, then one stress will be shown on right side, and whereas another stress would be shown on the left side. So AB is equal to the sigma 1 and AC is equal to sigma 2 after converting it on a suitable scale. So these are the values of AB and AC. Now we need to draw the perpendicular from B and C. We will draw perpendicular from B and C in above the line or below the line. Let's see how we can do. So BC, the perpendicular from B has been drawn, and it will be named as BF, whereas from C the perpendicular has been drawn as CG, like this. Now this BC, as in the last class we have seen that the midpoint of BC is the center of the circle. So again we need to bisect BC at O in order to get the center of the circle. So this point O is the center of the circle, and there is a little difference in this case as compared to the first two cases. In this case, we will consider O as a center and OG or OF as a radius. So with O as a center and radius equal to OG or OF, we have to draw the circle like this. So this is the Mohr circle. Now our task is to locate the oblique plane at an angle of theta. Obviously, in Mohr circle, we have to double this angle 2 theta. So we will draw a line from O at an angle of 2 theta from this line OF. So through O, we have to draw a line OE making angle 2 theta with OF like this. So in this way, the plane has been located, and this plane is plane OE in the Mohr circle, whereas actually it is at an angle of theta. Now from E we need to draw the perpendicular to represent the shear stress. So from E a perpendicular has been drawn. Now finally we need to join AE in order to represent the resultant of ED and AD. AD is a normal stress, ED is a shear stress. So join AE in order to get the resultant stress. And our results are like this. There are some notable points regarding this case, as we have seen that AD is the normal stress, and this normal stress could have two values. One may be maximum and one may be minimum. Maximum value of AD could be equal to when this D is being shifted to this point, that is this extremity, right extremity of the circle, or this AD is shifted to this point L, the left extremity of the circle. So AL and AM are the two minimum and maximum values of the normal stress. And these two maximum and minimum values are called as major stress and minor stress. Let me write it here. One is AM and one value is AL. AM is our major stress, major principal stress. So this AM is major principal stress, whereas this AL, this AL is minor principal stress. Now we shall take a numerical. So the problems are, as you can see on the screen. In first problem, a body has been given with these stresses: 65 Newton per mm square tensile stress and 35 Newton per mm square tensile stress, and a shear stress of 25 Newton per mm square, and we are asked to find out the normal shear and tangential normal shear and resultant stress on this oblique plane, which is at an angle of 45 degree. And for the second case, we have to consider an elemental cube which is subjected to tensile stress of 30 and 10 Newton per mm square on two mutually perpendicular planes, and a shear stress of 10 Newton per mm square on these planes. And we have to draw the Mohr circle of stresses, and hence or otherwise to determine the magnitudes and direction of principal stress as well as the greatest shear stress. So I will do only the problem number 1, and I will leave it the problem number 2 for your practice. Let's see how we can do the problem number 1. So we are given with the value of sigma 1, sigma 2 and tau. They are written here, and the angle of the oblique plane is at an angle of 45 degree, that is theta is equal to 45 degree. The different steps are like this. As I have told you, first of all we need to draw the horizontal line, and on this line we will represent the sigma 1 and sigma 2 after converting it on a suitable scale. So the suitable scale we shall consider as simplest as we can take. It is considered as 1 centimeter equal to 10 Newton per mm square. So the value of sigma 1 is equal to 65 by 10, 6.5 centimeter, and sigma 2 is equal to 3.5 centimeter when it is divided by 10. And similarly, tau can also be converted on this scale. So both the nature of sigma 1 and sigma 2 is tensile. That's why they are on the same side of A. So larger one is the value of sigma 1 and smaller one is the value of sigma 2. So that we can locate point B and C, and the midpoint is the center. So these are the value of sigma 1 and sigma 2, and the next step was to draw the perpendiculars from point B and C in order to locate this stress C, stress tau. So the length of the perpendicular is equal to 2.5 centimeter. So this is BF and this one is CG, and the length of this BF and CG is equal to 2.5 centimeter after converting it on a suitable scale. That was like this, that we have defined it. And midpoint of BC is the center. So we have bisected BC in order to get the point O. Then after considering O as a center and the difference, as I have told you earlier, that OG is the radius, or OF can be taken as a radius, or GF is the diameter. This GF is the diameter. Considering this as a diameter and O as a center, a circle has been drawn like this. So this is the Mohr circle. Now we need to locate this oblique plane at an angle of 45 degree, but here we will locate it at an angle of 2 into 45 degree, that is at 90 degree from this line OF, as you can see it from here. So at an angle of 2 theta, we have to draw a line OE. So this is the oblique plane in Mohr circle. From point E, we need to draw the perpendicular ED in order to draw the shear stress, as y-axis is for the shear stress, and this distance AD is for the normal stress, or this is the value of normal stress AD, and the resultant of AD and ED is AE. So we need to join AE like this, and once this triangle has been completed, we need to measure the value of AD, ED and AE to get the values of normal stresses, shear stress and resultant stress. So the value of AD is 7.5 centimeter. After taking the measurement, the value is 7.5 centimeter, and AD the value is 1.5 centimeter. So on converting it on the suitable scale, the value is equal to 75 Newton per mm square, and ED is 50 Newton per mm square. A is intentionally not written here because I want to solve it by your own in order to get the value of AE as well as the value of the major principal stress, that is this distance from A to this extremity of the circle, and the minor principal stress is from A to this extremity of the circle, this point. So these 2 points we have to take the measurement with a scale and multiply with this value. You have to multiply with this value in order to get the value of this minor principal stress and this major principal stress. So this was all for today. Thank you.